In question 2, we have to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. So let's take n to be some odd positive integer. We have to show that n is of the form 6q plus 1, 6q plus 3 or 6q plus 5. So how do you think we can solve this problem? Well, because the forms given to us all have 6 in them, 6q plus 1, 6q plus 3, 6q plus 5, let's apply Euclid's division lemma to n and 6. So what we'll get is n is equal to 6 times some quotient plus some remainder. So now the remainder r has to be less than 6. It can only take on values from the set 0, 1, 2, 3, 4 and 5. But can it take all of these values? So let's see one by one. Remember that n is an odd integer, so we will have to discard those values of r for which n comes out to be even. Okay, so if the remainder r is 0, then n is equal to 6q, and this I can write as 2 times 3q. So in this case n is even, so r cannot be equal to 0, so this case is ruled out. Now let's take r is equal to 1. In this case n is equal to 6q plus 1. Now this is an odd number because 6q is even and 1 is odd, and the sum of an even and an odd number is an odd number. So in this case n is odd, so r is equal to 1 works for the remainder's value. Now let's take the third possibility for the remainder, which is r equal to 2, and in this case n is equal to 6q plus 2. Now this is the sum of two even numbers, so it should be even. Or the other way to think about this is, if you take out the common factor of 2, you get 2 times 3q plus 1. So in this case n is an even number, and that's not possible because n is given to be odd, so r is equal to 2 does not work for the remainder's value. Next, let's take r equal to 3, and when r equal to 3, then n is equal to 6q plus 3, and in this case it's odd because 6q is even and 3 is odd. Again, the sum of an even and an odd number is an odd number, so in this case n is odd, so r is equal to 3 works. Then let's take r is equal to 4, the fifth case, and in this case n is equal to 6q plus 4. Again, we can see that this is the sum of an even and an even number, so it should be even. Or the other way to think about this is, take out a common factor of 2 and you're left with 3q plus 2. So in this case n is even, so r is equal to 4 does not work. And finally, if we take r is equal to 5, what do we get? We get n is 6q plus 5, and here we have an even and an odd number, so n is odd, so r is equal to 5 works. So the possible values of the remainder can be r equal to 1, r equal to 3, r equal to 5, because for these values of the remainder n is odd. What the values that do not work are r is equal to 0, r is equal to 2 and r is equal to 4, because for these values n comes out to be even. So because r can take on only 1, 3 and 5, these values, we see that n can only be of the form 6q plus 1, where r is 1, 6q plus 3, where r is 3, and 6q plus 5, where r is equal to 5. So that's how you can solve this question. To learn more about how QMath can help you crack school and board exams, explore QMath Leap.